it's harder to determine what you're supposed to do in this one. Like just which test you're supposed to do.
Yeah, when they all come together, yeah. But I'm not trying to get into medical school, so.
Yeah.
So I'm not as stressed as you.
Well, I wasn't too stressed about this class. I was thinking about my physiology class.
That's the one. I have a pathophys test today that is going to just kick my trash.
Good luck, you guys.
Well, thank you.
All right. Let's see. Question 2. I hope they're exactly the same question.
Yeah, I hope they're in the same order. Looks like they are.
They are. Good. Okay, so for number 1, I put C.
I put A.
What? You mean number 2?
Oh, yeah.
Okay, sorry. I'm like, oh my gosh, I'm already wrong. Okay.
Oh, no.
But,
Yes, we all attended the group meeting.
yes.
So I guess number
Okay.
2. Sorry.
Okay. So I put A. We are 90% confident.
And that's what I put.
So then what's the one, because on the one that we just did, it was we're 95% confident that 95% fall within the confidence interval. Because that was just on our last homework assignment.
Right. If I recall that question, it took the same thing. It said, if you're given 90% confidence interval, we could also say that we are 90% confident that true mean is between these. And then it asked, what's another way of saying it? And I got that one wrong both times. I'm like, I don't know. I only know the one way of saying it.
Oh, see, so the second time, I got it right. I got it wrong the first time, too. But the second time I said, there's a 95% chance that 95% of the people fall within that thing. So that's why I chose this one.
Right. I think I looked, yeah. So that ended up being the right answer, right?
Uh-huh.
Right.
Well, on here, they're saying the mean heart rate. So maybe that's why we're focusing on. That's where my logic came from doing A.
And I think Julie just said made sense to me, but there aren't any of these that are quite like that. Like the ones, Julie, I think what you said is there's 90%, let's say 90% of, how did you say it again? It's like 90 of 90 or something like that?
Yeah. But maybe that was when they were comparing means of 2 different groups or something.
Oh, because you're saying 90% of all the people have a heart rate. And this one's, we are 90% confident. Maybe because it says confident in the question. There's a 90% confidence interval.
Well, let's go with A. I think, I'm wondering if the exception to that falls when you compare 2 group means, like when you do the paired test or something. You know what I mean? You state your confidence level different.
Right.
Yeah. Yeah.
And this one,
Right.
I just looked this one up in our book, and it is, we are 90% confident.
Okay. All right, so the next one.
Okay. You want me to read that? Okay. Did you guys already do this?
I did.
Yeah, I went through and did them all.
Okay. Should we just see if we all have the same?
Mm-hmm.
Yeah. So I put B on the next one.
I put B.
That's what I did.
Okay, good.
Yay.
Okay, so the next one I put D.
I put D.
Yep.
The last one.
Yes, me too.
Okay.
Okay, 5. I put C.
Oh, I put B.
You
I
put
put
B.
B. Yeah.
Okay, I'm sure I'm wrong out of the 2 of you.
Yeah. Well, and I was thinking C, and then I looked it up, and it turns out if you did a 99, that would actually increase.
Yeah, it makes the thing bigger. This is the one, remember, if you have more samples, then your confidence level narrows. If you have a bigger confidence, then it makes it bigger because it has to catch more.
Okay. Okay, that's good. That's good to know.
There's just values there.
6. I got A on that one.
I had A.
Oh, great. I got B.
Oh, you actually got, which formula did you do?
So I didn't do a formula. I just said, well, 95%. That would be 2 standard deviations away, which would be about 1,004, and then 996. So did you guys actually calculate something there?
Yeah.
Yeah,
What form did you use?
Well, which formula is this?
I did the X bar plus or minus the Z, whatever it's called.
The confidence interval.
Okay, so this is where we do like 1.96
Yeah.
times 2.
I
Times
and then-
did 2 over the square root of 4, which was your sample size.
So you take 1,000 plus or minus 1.96 times 2 over the square root of 4. Or, yeah. So
So
it gave us exactly 1001.96 as the high.
Okay.
and
Okay,
then
that makes
low.
sense.
Yeah, 998.04.
Okay, yeah. So A.
Okay, then on 7, I got C, which I also did the formula for this one.
Yeah, I got C on this one.
Okay, good.
Yeah, I remember. All right, so for the one we just did, I hadn't found the formula yet, and then on the one, okay, we're good.
Yeah,
C.
so C we were solving for N, and they gave us that formula.
Yep.
Okay. Okay.
All right, so for 8, I had A.
That's
had
what I've
A.
got.
Okay, good. 9,
I've got B.
I got B.
That's what I had too.
And
10, I wasn't completely for sure.
I was thinking it was A.
Because we have a bell-shaped, wait, yeah, A, yes, it is enough data for the, they are bell-shaped.
Because if you agree the answer is yes, then the difference between those 2 top answers is you have a small sample size. You only have 15, so your central limit theorem doesn't apply. And
Okay,
the
but
bell
if you,
if you have a bell shape, then it means that you're normally distributed.
okay, but an ANOVA, though, is right, it's not
It
bell-shaped.
is. You're right.
An ANOVA only has 2 requirements. The data needs to be normally distributed, and the variance can't be more than 4 times.
Okay, so it doesn't even matter what it says here if it's bell-shaped.
But it tells us that the
no, it
sample
does.
variances are
Bell shape matters.
nearly equal.
Oh, it tells us that they are equal.
So the difference that you're talking about, which I understand because I had that same question as I went through it, but we're not talking about how to get the p-value from the ANOVA. We're talking about what qualifies your data to be able to use it. So always, 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 you have to have a normal distribution of your data. So in order to do that, you either have to have a high sample size or you have to have normal distribution or bell-shaped curve. Does
Okay,
that make sense?
yeah, no, it does.
But you're right, it is a right skewed with just a one-sided tail test. But we're not talking about the test, we're just talking about the qualified to be able to do the test.
To do the test, okay. So you guys did what, A or B?
A.
A.
Okay. All right.
So the next one I put a type 1 error.
I did A also.
Yep.
Okay. And then 12,
D.
D,
That's
Yeah.
what I got.
that too. Okay, 13, I haven't, 13 I was confused, so I wasn't sure on this one.
I
Alright,
put
well,
fail to reject the null.
Me too.
And you did that, where is it? A?
B.
B.
Oh, B, failed to read, sorry.
Correct.
Okay.
So I plugged it into my Z formula. Just the plain old regular one where you still knew what sigma was.
Okay, so
Brian?
I did it, but I got a 1.765 as my Z-score.
But then that's your Z-score, but then you have to open your probability applet
Oh,
and put that Z-score in your probability applet, and you come up with a probability of 0.0776.
0.0076.
Yeah.
Okay.
So then that makes your P greater than your A, so you have to fail to reject.
Okay.
Does that make sense?
Yeah.
You
That's
were
what I
all
got.
there. You just didn't do the very last step is all.
Yeah. I was thinking, do I open the applet in this? But then I wasn't
Yeah.
sure.
Yep.
Okay. Okay. 14. I did B, but I don't know if that's right. Independent sample t-test.
Yeah, that's what I said too.
Okay.
But this is where I get iffy. All right. Is that what you said too, Ryan?
Sorry, I was having a hard time hearing you guys.
Yeah, I can't. What's going on? Why is it so low? I can hear.
He's not in the quiet of his house.
Well, my house is quiet, but it sounds like. Who's the other person in our group?
Josephine.
Yeah, it sounds like Josephine's there, but I can't see her.
I think Ryan's sitting in a hallway at school.
Yeah,
Oh,
is that it? So when I turned off my microphone, did it get better?
Uh-huh.
Okay.
Yeah, but we want to hear you, so it's okay.
Yeah, we definitely want to hear you.
Yeah, okay.
Okay, so what are we on now? 15?
Well, so 14,
Oh,
Ryan, did
14.
you say independent sample t-test?
Yes.
Okay, good.
All right, so then 15, I had D.
I put B.
And I put, yeah, B.
B. Okay,
Okay,
so let's see. But shouldn't it be a dependent sample because you need the brother hooked to the specific sister?
Oh, see, I
Wait a
was wondering
second.
between, I either thought it was either independent sampling, I either thought it was B or D.
I think it's because if you have the first one attached to a specific second one, then that's your dependent sampling.
Okay,
So you want a specific brother, then that gives you a specific sister, then that's a dependent, not an independent. The independent is like when you have boys and girls and you pick one boy and it doesn't matter what girl.
okay, yeah, that
Does
makes
that make
sense. I remember.
sense?
Yeah. Yeah, but not C because that, yeah,
Because C, her academic achievement doesn't
does
depend
not
on
depend
him.
on him. Okay,
No, it just, if you pick him, then she gets chosen because
Yeah.
they're a pair.
yeah,
That
That
match
makes sense.
their thing.
yeah. But I couldn't remember if it was dependent or independent. So yeah, I think it's D. Okay, ready to go on? You're
Yep,
good?
I'm ready.
Okay. 16.
B.
I got B as in boy.
That's what I got.
Okay.
And 17, I got D, 11.168, 15.217.
Yep, I got that too. Okay.
Okay, so then 18, I had D, the confidence interval for the difference of meetings using independent samples.
That's what I got. I got D.
That's what I got.
Okay. And 19, I got C.
That's what I got.
Oh, crud. See, I put A.
Oh, you did?
Uh-huh.
Let's see how I did that.
So
Hmm.
did you do an independent sample t-test?
This
I
one you
did.
have to recode. It was confusing because you have to recode the city.
Yeah, and I did that. But then I plugged it into my independent sample. I wasn't sure on this one. That's why I have written exactly what I did, because I didn't know. But so if I did an independent sample t-test, then I came up with this A.
Hmm.
So how did you guys do it? Which test did you do to get it?
I thought that's what I did. I'm pulling mine up here again to see.
I know I recoded. I think I did an independent sample t-test. Why didn't I write that
Well,
down?
I very easily could have done the wrong thing. So just a minute and let me.
So recode the city.
City. Yeah, I did. I recoded the city.
What was the name of this one? I can't remember.
It's used Hummers, New York and LA.
So the price is our test variable, and the city was what we recode.
Right. And then we want to do a independent sample t-test.
T-test, yeah.
And for test variable, I'm going to take price. Grouping
Yeah.
variable, I'm going to put our new our
The
city code.
that you recode, yeah.
And then, do you have to define groups? I just defined them as 1 and 2.
1 and 2. I did 1 and 2.
And then I push OK. And what's this one asking for again? It's our 95%.
The 95 confidence.
Yeah, the intervals between.
And you go with the equal variance is not assumed, and you get negative 423 to 5417.
So do you see the 770? Where did I pull that off?
I don't see anything in here that says 770.
I bet you just missed one step, Julie.
Okay, just a second. I'm trying to try it again one time. Okay, so I transform, now I analyze, compare. Oh, maybe I did. Do we do the one sample t-test or independent sample t-test?
You need to do the independent.
Okay, I think that's what I did. And then for your test variable, you put price.
Yeah.
And then grouping, put your recoded. And we're at 95%. Yes.
And then you have to put a grouping.
Oh, you guys. Okay, look. So our numbers are right on top of each other. So you do the top one or you do the bottom one?
The bottom one.
The bottom one.
Yeah, we always do equal variance is not assumed.
Oh, okay. That's the difference.
Not
Gotta
assumed.
make me a thing.
Oh, you did the one of, okay, see I saw the 769 and I didn't equate that to 770. Sorry.
Yeah, no, it's all good. Okay, so you use the bottom.
Yeah.
I remember that now. Okay, so that's 423. Awesome. Good. Okay, sorry.
No, it's good.
All right.
The next one I got a Nova.
I did too.
Wait, E. That's the
Yeah.
Yeah. Me too.
Got a Nova. And then I got C on 21.
7.978.
Yeah.
Two. And then the .002.
2.
Yep.
Yeah. And then 23.
I got B as in boy.
Me too.
Yeah, I did too. Okay.
And then 24, I did C.
I did C.
Me too.
And then 25, I did A. 1.685.
Yep.
Yep.
And then the next one I got .096.
Me too.
B.
Yeah. And then the last one, then I put C.
Yes, that's what I put.
C is in cat.
I put B as in boy.
B is in boy.
Yeah.
Okay. Okay.
Because they changed the confidence interval. It's not the usually .05 like they use all the time. It's .1.
Right. So we missed one of them. We missed number 13.
Oh.
Number 13 is reject.
13. What did we do wrong? Oh,
The
it's
answer is-
greater, so you're gonna.
It says the answer is reject the null.
D on 13.
Yeah.
Okay, so I wondered about this as we, wait, no, that's a different one.
It's the
So let's look at what we
opposite.
did.
It was the opposite of what we were talking about. When the confidence interval, we had a .007, but that's higher than the .005. So, wait.
Well, so let's.
Yeah,
So
I'm
you
confused.
reject it.
So you need to reject it. No, I would think fail to reject.
So which equation did we use here again? We use the.
We use the Z
Z-score.
equals the X bar minus mu divided by sigma divided by the square root of n.
Wait, what? We do the
The
The M-
Z-score. So you would write it out 1.53 minus 1.5 divided by 0.17
Oh, gotcha.
over 100 square root.
And then we took that and put it in the probability applet, but apparently something we did was wrong.
And that's one where I only got to the
Because our z-score should be what, 1.96
Oh, I had 1.765.
for a 90%. Oh wait, that's right. This one we have to.
Yeah, it's 1.5 because they give it to us. We don't use that percentage.
Wait, they don't give us a z-score in this problem.
I know, we figured it because they give us X bar and they give us mu and they give us sigma.
If I were to put it,
And so that's why I was solving for Z.
And it says you're supposed to reject it?
Yeah.
D, reject the null.
Oh, you know why? You know what we did? We failed to cut our stupid thing in half. Because it's a one-sided test. So when we get P of 0.0776, we should have then divided that by 2 because we just want to know our hypothesis is less than, it's not equal to.
Oh.
Divided by 2,
Would be point.
and that makes it less
3.
than sigma. That's exactly what we did wrong.
so a carbonyl is just
Wow.
a ketone with a carbonyl group in the middle of a carbon chain, and all the
Is that
hydrogen.
Ryan?
Yeah, that makes sense. I'm still doing the math myself, but so
So is this going back to our unit 1? Because we haven't been using applet. So is this something that we should have known before? I mean, did
No,
we
I
use
don't-
the applet this?
I think we've used applets just clear back at the beginning when we still knew what sigma was. Then we stopped knowing what sigma was.
Yeah, and stopped. But because we did know what sigma was, then that gives us the key that we can use the applet.
wait. So what did you guys get for your z-score again?
1.765.
Okay. So I got to go 1.53 minus 0.17.
No, 1.5. You're minusing 1.5. That's the mean of the cigarettes is 1.5.
Oh, sorry.
Well, so we do
1.5.
X bar, so 1.53 minus the mean, which is the 1.5.
The 0.17 is the mu, which is divided by 100 square root.
Yes. Then divided by 0.17, which is sigma,
Oh.
by the square root of your sample size, which is square root of 100.
That's the, okay, that part I was forgetting there. So you get, oh wait a second. So 0.017?
for the bottom number divided by 0.03.
And you do 0.03 divided by 0.017.
Okay. Thank you.
Yeah.
So-
that's-
Yeah, we haven't used that formula in a few weeks. I totally
I
forgotten
know.
about that.
That's-
And the test is going to have all